Good. Oh. Okay.
Yeah.
You guys picked up the worksheet 2, but I want that for you guys to work on at your own time. In class, we'll do worksheet 1, which is on page 26 in your packet. Now, the handout that you just picked up, however, has the key for both worksheet 1 and worksheet 2. So I really just want to give you guys the time to work through these problems as much as you can on your own. But I'm also going to spend time to just go through the solutions and make sure that you're good with everything. Because I would say, a good number of you are planning to take the quiz tomorrow, so we'll treat today as a review day. I will be available tomorrow morning to do help session 7:30, and then also Friday morning 7:30. For help. Okay. So let's start with number 1 here. Let's say I did not tell you that this was an ellipse. How would you know that this is an ellipse? It's the same sign and different coefficients. Same signs, different coefficients. That's an ellipse. Okay. So you're going to group the x's together, group the y's together, and then constant on the other side. Now with ellipses, I always have the x comes first. Now, if you decide that you don't want to do that, that's fine. But typically, the standard form has the x always coming first, and then you're looking at the a value. You're looking at what's greater in the denominator, and that's going to be your a value, your a squared value. So put your x together, put your y's together, and then put the constant on the other side. That's right, calculator.
It was like front and back.
Front and back, yeah. Again, if you're working ahead, you can check your answer with the key that I have attached to the handout I just picked up. So the handout has both the keys for worksheet 1 and worksheet 2. GCF of 9 comes out on the x side of things. 16 comes out as your GCF for the y's. Okay, we should be able to get all the way down to our standard equation before we do anything else. Standard form. Notice the 16 is larger than the 9, so you know the 16 must be the a squared. The 16 is under the x, so you know that your ellipse is going to open wider left and right than it is top to bottom. Okay. Horizontal major axis, vertical minor axis. The formula is also a little bit different. It's c squared equals a squared minus b squared, right? Hyperbola is c squared equals a squared plus b squared. We have to make sure that our c value is smaller than our a value because our foci will be inside the ellipse.
Is the one that's greater.
Okay, once you know your orientation of your ellipse, you can just do a rough sketch. It helps you. You know your vertices is to the left and to the right, your co-vertices is above and below. If you're good with one, go to number 2. This is number 2 and 3 is where you have important information of the characteristics of the ellipse, and then you're going to have to use the graph to maybe help sketch out enough information so you can find the a and the b value. Once you have your a, your b, and your center, then you should be able to create your ellipse equation in standard form. Go ahead and try number 2. The fact that the ellipse is tangent to the X and Y axis, that tells you how far to go. You know, your ellipse has to skim the surface of the X and Y axis, and that's going to help determine your A and B values. And based off the location of the center, you know that you're moving further away to get to the X axis. So therefore, this must be a vertical major axis. So you know that your A value or your A squared will go under the Y and your B squared will go under the X. This is wrong here. It should be. Number 3, you have the picture of the ellipse in front of you. Identify the center. Distance from the center to the further endpoint will be your A value. Distance from the center to the closer of the endpoints will be your B value. And then decide, is it a horizontal or vertical major axis? And from there, you can decide whether to put the A squared or B squared under the X or the Y. If you're good with 26, go to page 27. The difference with hyperbola is making sure that we understand the A value is always the positive one. Okay, so we want to think that we find the A squared the same way as ellipses, right? We don't want to look at that 49 and think, oh, that must be the A value. This is a hyperbola, so it's the Y squared that's positive. So whatever is under Y squared will be your A value, right? It's okay for the A value to be larger or smaller, or even the same value. Okay, but we want to make sure we switch gears a little bit when we deal with hyperbolas. Your a squared is always positive, is always first. Okay. Your a value will get you to your vertices. Your b value will get you to your co-vertices. From those 4 points, you're going to create a rectangular box, and then you're going to go from corner to corner, create an X that will act as your asymptote lines. And then also a different equation for our c squared, right? C squared is not a squared minus b squared, c squared. C squared is a squared plus b squared. And your both side will always be outside of your arcs. Okay, it'll always be the furthest point away from the center in your graph.
How do you know like the c squared? Like how do I see? How do you know if c squared equals a squared plus b squared or c squared equals a squared minus b squared?
Right, so for hyperbolas, it's c squared equals a squared plus b squared.
And those are the opposite.
Minus, that's right. Ellipses is going to give you a squared minus b squared. Yeah, so maybe a way to think about this is that your sign will always be different, right? So c squared, a squared minus b squared, different than the sign if you x squared and y squared plus this with the minus. So there's going to be a little bit of opposites going on with the two equations. Okay, now once you draw the blocks, you know your vertices are above and below, so your arc is going to be opening up and down. And then make sure that you're comfortable writing your asymptote equation. Y minus k equals plus or minus slope x minus 2. And the slope, you're always going to go from the center to the upper corner and always do rise over run. Rise over run. Make sure you put a plus or minus in front of it. And then your eccentricity is root c, c over a. Right. Yeah, so that's right. So transverse axis is at points. So transverse axis and that from vertex to vertex. So that will help you get to your a value. Whole thing, right? Yeah, so as a reminder, transverse axis connects from vertex to vertex. So it's always going to be double the length of your a value. Okay? And then your conjugate axis will connect from co-vertex to co-vertex. And that length is always going to be double the length of your b value. Okay, number 5, complete the square. Just have to worry about the fact that whatever comes second with a negative, we got to make sure we factor the with that negative correctly. So yeah, so practice your steps for number 5 as you complete the square. You know it's hyperbola because your x squared and y squared offers different sides. It doesn't matter if the coefficients are the same. They could be the same, but it's the sign difference that we automatically know it must be a hyperbola. Your second, your y variable has a GCF of -9. So as you factor -9, make sure you change the sign here as well. -54 divided by -9 is a +6. So just be careful with that adjustment with that negative in front. Now, when we complete the square, You're always dealing with a plus space on the left side of your equation. When you get to the right side, after that GCF in front, it may change the sign of your spaces, but within on the left side, as you're building your p-value for complete the square, your space will always be these must be positive values. Okay, always positive. Okay, a squared is always first, b squared is always second, right? Don't look at the size. Look at this, look at the what's first.
Just allows for speaker centers here.
Yes. That's right. We got to do decimals a little bit. Okay, page 28. Again, transverse axis will connect from vertex to vertex. Conjugate axis will connect from co-vertex to co-vertex. I think copy zeros. Yeah, that's the- There's some space on the bottom part of your packet. If you guys can write this down, this is number 7, A, B, C, and D. So just want to know, which one is the circle, which one is the parabola, which one is the ellipse, which one is the hyperbola. The trickier thing here is that the x squared and y squared are not on the same side of the equation. So you want to move those terms to the same side of the equation before you make your decision, comparing the coefficient and the signs and all that. So. And again, it's only the x squared and y squared that we care about. At least for isosceles is not a parabola. Parabola should be easy to spot. Okay, I'll go back to number 6. If you guys haven't finished looking at that, but I want us to have a chance to write down number 7 first. And let's make sure there's not actually values that, I just made up some of these numbers here, which. Okay, what do you think A is? So once the 3y squared comes over to the left side, x squared and y squared are both the same signs. Okay, but we know it's not a circle because coefficients are not the same, right? If it was 3x squared and 3y squared and they're both the same signs, then we know it would be a circle. But yeah, this is an ellipse. Okay, B should be easy to spot. What's B? Parabola. There's only one variable that's squared, right? So. What about C?
Hyperbola.
Hyperbola. The tricky thing is that the 4s, they throw you off and think that maybe it's a circle, but once you get them on the same side of the equation, it's a 4y squared minus 4x squared. As long as their x squared and y squared are opposite signs, it doesn't matter what the coefficient is, it's always going to be a hyperbola. Yeah. In part D, once you get the x squared and y squared on the same side, circle, yeah, same signs, same coefficients. Circle.
So the quiz will be like cross elimination. It won't be like one that has like multiple, like it's same.
You have
It
to make
could
that
be like
decision.
2 ellipses and like no circle at all. Like it'd be one like that.
I'm sure to ask if it's gonna be like in this form of any circle.
Yeah.
Yeah, I mean, it's just possible that I only ask, there's only 3 options and there's 4 choices.
Oh, okay.
But either way, you have to make your decision.
But the choices aren't gonna like repeat themselves, right?
Two separate problems.
Probably not. Let me go back to number 6 in case you guys need to look at that. Any questions? Okay, let me talk about tomorrow for a moment. Tomorrow morning, again, I'll have a health session, 7:30, in case you need it. I'll go over worksheet 2, the one that you just picked up. When you get come into class, the quiz won't take the full period. So I'll give you guys 5 minutes for those of you taking the quiz to look over your notes, and then we'll start the quiz after 5 minutes. I'm gonna need everyone to put up their phone, even if you're not taking the quiz. So if you're not taking the quiz, you can just find something to do, find something productive to do. Either you can work on worksheet 2, or you can do something else. Right, it's up to you. But we have to just remain quiet for the students who are taking the quiz. Okay. And then Friday morning, I will again have a help session. And for those who are taking the quiz on Friday, again, I'll give you 5 minutes to study at the beginning of class, and you'll take it after 5 minutes. Okay. Make sure you look over your formulas and your notes. Okay, so this, I want to just make sure that I went over this because I neglected to go over this big thing that I should have gone over at the very beginning. It's the idea that, why is it called a conic section? Why are these conics? The reason that they're conics is because they're called conics because these are the shapes that come out of cross sections when we're dealing with cones. Okay, they're coming from the shape from cones. So if I do a cross section of ellipse, like on a slanted along cone, it's going to create an ellipse. If I were to take a double cone and put them end to end, and I were to do a cross section of that, that will create the shape of a hyperbola. Okay. And then a parabola would be taking a cone and doing a vertical cross section. That's a parabola. And then if I were to take a sheet of paper and I were to do it evenly, not on a slant, that would create a circle. But as soon as it slants, it will become an ellipse. So call the conic section because these are cross sections of cones. Okay. All right, come get your phones. If you're taking the quiz, make sure you spend time to go through worksheet 2 if you feel like that will help you prepare more.